All right, I think we're actively recording now. Let's go ahead and start with the self-introductions. I'll just kind of go down the participant list that I see in front of me. And hopefully people are kind of added as they come in, but I suspect that's not going to be the case. I'll go ahead and start. So my name is Rune Storson. I am a researcher at Center for Catastrophic Risk Management. My background is on the civil engineering side, and my research interests are aligned with safety and reliability of critical infrastructures. So next I'll go into Kathy Schaefer. You can turn your video on for the little introduction part.
Hi, I'm Kathy Schaefer. I'm a researcher, PhD candidate at UC Davis, and my interest is in flooding and flood insurance, and how can we monetize our risk our flood risk to better mitigate our flood risk.
Cool, thank you, Kathy. There's a dial-in number of 514-772-9035. Does that belong to anybody? Going. All right, Emery Rowe, you're next. Are you out there, Emery? Mm-hmm. Okay, we'll cycle back to Emery. I see Mark as a guest. We're doing self-introductions now. So for those clicking in, if you're Mark, I'm going to give a little snippet of your name and kind of background and interest in risks.
Yes, can you hear me?
Yes.
All right, my name is Mark Nichols. I am working with a group called Citizens Acting for Rail Safety, and my particular interest is the transport of hazardous materials by rail and the prevention and control and response to those kinds of incidents. So I'm very interested in today's topic and how it applies to those situations.
Great, thanks, Mark. How about Gianpaolo? Welcome back.
Thank you, Ron. Thank you. Can you hear me?
Yes.
Yeah, sorry, my bad connection. Well, I'm a civil engineer. I'm an Italian civil engineer with a degree from Polytechnic of Milan. I worked with companies such as Tesla here in Italy. And now I'm in the United States, where I'm part of an MBA at San Jose State University. I'm interested in developing my knowledge in sustainable mobility. Thanks.
Great, thank you much. Heather. Are you out there, Heather? Going. Ian.
Hi, Ian Mitrov. I'm a member of CCRM, and my research concerns complex, messy systems and crisis management.
Thank you, Ian. Is it Dragan?
Hi, everybody. My name is Dragan Komnjenovic. I am from Hydro-Quebec in Quebec, Canada. And I work as a senior research scientist at the Hydro-Quebec Research Institute, IREC. My field of expertise is in risk analysis, engineering, asset management, and I previously worked as a reliability and nuclear safety engineer. So the topic of those kind of subject is highly interested for me.
Great, thank you so much and welcome. George Lane.
Yes, sir. Can you hear me?
Yes.
Okay, I am George Lane in Louisiana. I recently worked with, I guess, as a research associate by a company for CCRM with a grant from California Office of Emergency Services on a chemical detection system, primarily at ports. The goal being keep the ports open by providing chemical security. We have one, by the way, in operation now at the port of Redwood City, south of San Francisco.
Cool. Thanks, George. Natalia.
Hi, everyone. My name is Natalia Smaluk. My background is in reputation management and crisis communications and leadership. I own a firm called NBAU, which stands for Not Business as Usual. And I'm very interested in all scenarios of crisis and change. And currently, I happen to be working on an international infrastructure program related to public-private partnerships. So this is very much of interest to me. Thank you.
Cool. Thank you. Welcome. Patrick.
Hi, my name is Patrick Lamb. I'm an engineering geologist with NGO. I guess the lighting's really bad on the video. Like I said, I'm an engineering geologist with NGO. We work on infrastructure projects, both public and private. And I also have a affiliation with Berkeley Haas Exec Ed in their data science program.
Cool. Welcome, welcome. Peter Martelli.
Hello, I'm Peter Martelli. I'm an associate professor of healthcare administration at Suffolk University and a longtime member of CCRM. And I just found out yesterday that I was approved for a Fulbright scholarship to help establish a movement for reliable healthcare in Georgia, the country. So that's going to be interesting, and I look forward to discussing it with all the CCRM members soon.
Cool. Congratulations. And Sarah.
Hi, my name is Sarah. I am a PhD candidate at UC Berkeley in the Department of Environmental Planning, and happy to be here. Thanks for me.
Cool. Welcome, welcome. All right. Does anyone else want to go that didn't go? I see Heather posted a chat here for everyone. All right. I got
this is. I am the 514-772-903. This is Jean-Raymond speaking from Hydro, Quebec.
Okay.
Let's say I'm involved to bring the company in the future in the digital transformation, and one aspect is to deal with the climate change. So and I'm working also with Dragon on the reliability studies, safety studies, and so on. So let's say for me it will be an introduction to risk management.
Oh boy, sounds good. All right, anybody else on introductions? Okay, going. So I'll do a quick little overview on the center and then do the speaker introduction. We'll probably wait for questions until the end. So if everyone can put themselves on mute and turn off the video, that would be helpful. And then at the end of the presentation, we can all click on the videos again and unmute as necessary. So before we begin, just some background on the center. The Center for Catastrophic Risk Management was founded in 2005 in the wake of Hurricane Katrina. We're a global group of applied researchers from academia, government, and industry who have come together to develop pragmatic solutions for the complex, multi-jurisdictional, messy problems of the 21st century. We conduct fundamental research on catastrophic risk through empirical data. By identifying and engaging targeted teams whose expertise are uniquely tailored to each challenge, CCRM aims to make the intractable manageable. And I'm excited to introduce our speaker for today. Wendy Wheeler has been transforming chaos to clarity for over 20 years. She's a skilled crisis manager with extensive experience in disaster preparation and response. At BART, Wendy's focus area are digital transformation, data analytics, automated train operations, fare collection, operations technologies, control systems, and operational support. Her agile and enterprise software experience at HP provided her the tools required to lead BART's operations technology software development and digital transformation projects. She also worked at Bank of America, where she was the manager vice president of network operations and provided 24/7 operational support and coordinated disaster recovery responses. At BART, she provides support and technical expertise in the Emergency Operations Center. And I'll also add in the conversations that I've had with Wendy over the past few weeks, I think what you're going to see here is a wonderful illustration of leading indicators put into action and definitely being part of the risk reduction program. So with that, I'll turn it over to Wendy.
Thank you very much. So the topic today is designing systems for adaptability and resilience in uncertain times. And as we all know, these are very uncertain times with COVID and global warming and all of the other challenges that we face. So the agenda for today is I'm going to kind of do a background on digital transformation. I'm going to talk about weather because that impacts rail operations, give a little bit of kind of an overview of what we've been doing for train control and plant operations with digital data and with some of our capital projects that we're working on, talk about fire and our PSPS response to that and how we mitigated our risks at BART in that space. COVID, which I know is near and dear to everybody's heart lately because no one has gotten away with not being impacted by it, and elements of digital transformation management found appealing. So where do you focus your efforts when you're trying to get management to kind of buy on board? And also the lessons that I've learned over the years on how to transform and reduce risk and implement digital transformations. So let's just talk about data. As we all know, the industry has changed so much over the years, and now data is the new oil. It is transforming every aspect of our life, from the cars that we drive that communicate with your house, to the Uber driver that picks you up to take you around the corner, and into industry to streamline the way we do business, and also in transportation to be able to mitigate risk and manage our operations more effectively. If we look at the Fortune 500 companies, where technology or where the big money has been over the years, you go back to 2001, it was, Microsoft coming up with hardware and new software, but you had still brick and mortars like your Walmarts, your banking industry, your oil companies. Fast forward to 2016 and the landscape totally changes. You have all technology companies, and all of them are based on hardware, software, and digital data. So let's talk about how things have changed in transportation with digital transformation. We have organizations that monitor our progress, and their iceberg and comet studies that have happened over the years. Iceberg did a study in 2017, and from the look at transportation, it was really a laundry list of stuff we wanted, right? There was no cohesiveness. We were all struggling to figure out what we wanted to do with our data and our systems, right? Go to 2020 with the comet study, you start to see a framework kind of hanging on. A lot of agencies are starting to kind of get their arms around the problem. Fast forward to today, we're in the process of working with Iceberg right now for their current study, and what you're seeing now are real roadmaps and best practices. And what does that really mean for us is in digital transformation, the early stages are kind of that development level, coming up with digital information and initiative plans, having little pet projects, trying to get your arms around those kinds of things, but it's really more kind of grassroots, not real strategy at that level, right? You move up to a more intermediate state where you are starting to integrate critical systems and trying to really see where you have data or what you can do with your data. And then as you move into this digital transformation, you move into this advanced phase, which is convergence. And you have in agencies transformative projects to improve your digital channels. And you're also seeing the systems finally being integrated. And then if you really hit nirvana, which nobody really has, which is, innovation and adaptability, and actually having your entire transit agency using that data extensively. That's nirvana. That's where we all wish we could be. Most of us in the transit agency are at that intermediate level where we have lots of multiple systems, and we're desperately trying to integrate and improve our operations. There are actually three approaches that you can take to digital transformation. One is this top-down approach where you have real strong leadership, you funding initiatives. It's having a vision, right? This strategic plan that everybody is marching towards. Normally, these initiatives are out of the IT department and everybody is focused on the transformation. Not common, but normally the best approach. Bottoms up approach is grassroots. You have a bunch of people in operations that are struggling to do their jobs. You piecemeal things together. It's kind of a loose framework. All the budgets and the priorities are set by line staff that are just trying to get work done. It really lacks cohesiveness. Each individual project is cohesive, but together it's not kind of a vision. And then the other approach you have is kind of a hybrid where you have major projects that are highly funded that can help build the infrastructure to the bottom up, but you still have these grassroots projects that are happening that may not tie back, that management may not even know is happening, right? And so that's kind of how things are. We at BART started with both the large initiatives that are capitally funded having this, high management sponsorship, and also these maintenance level initiatives that were more bottom up grassroots out of desperation. So we're kind of in this hybrid method, and I'll talk more about that as we go through the presentation. So what were our goals for our digital transformation? We have a lot of money right now to modernize our very, very old infrastructure that is from the 70s, 80s, 90s. And so with that money gives us an opportunity in a major way to modernize our technologies and build our digital channels as we're doing it with those funds, to enable us to move from this very reactive old technology into a more proactive space. With doing that, we can also reduce our maintenance costs, and the side effect of that is reduce costs and also improve service at the same time. Reduce delays, provide information to customers more effectively, and all of this equals reduced risk and a safer transportation agency for us. We want, and our top priority as a train operator is to have the safest possible system for our riders. So a few years ago, we took a step back and we started looking at our data, and we have a lot of data, but in a lot of different systems. And so we have about 12.8 million log records a day on a good day. On a bad day, we have a lot more than that. We also have destination signs that spew out information to customers, 750, actually a lot less than that with COVID because we're running a reduced schedule. And we also have all the field indications from the SCADA devices in the field that are just yelling at us constantly. But as you can see, this is so much data for the human eye to kind of absorb, right? And it's just coming at such a rapid fire rate. It is impossible for just anybody to manage it. So we wanted to take all of these systems that we had, and we wanted to integrate them. And so originally we had limited integration, and now we're trying to move into more integration, right? So let's talk about the journey we had a few years back. Our IT department acquired a product called Splunk. It is used to do visualizations and data analytics of data, and it's great at that. And I said, why do you guys get this cool tool? I work in the OT and operations technology. So there's a clear line between our IT department that handles all the back office products and OT, which handles the plant. And I said, how did you get funding for this cool toy and I don't get to play with it? And they said, oh, by all means, you can have it. We'll give you your little place in the world and you can start dabbling in this. And I will have a lot of examples below in the presentation to talk about what we've done with dashboards, and that's been a game changer for us. Then what happened next is we are got a big amount of money and have been working on a project called computer-based train control, CBTC. And with that very expensive project to transform our legacy train into this computer-based train control system, we needed a foundation to be able to merge our old legacy train control system with the new Hitachi ATS system that is coming online. And we needed a framework or a district channel that we could pump all the data in and run those systems together at the same time seamlessly. And in addition to running the train seamlessly with two systems as we're migrating to the new, we have actually needed to keep all of the subsystems that we supply data to accurately displaying information to customers, to our customer support people, to our other stakeholders within BART, to our operations and maintenance partners. And we had to do that all seamlessly. And, you know, that sounds easy, but it's not easy. And so we, through that project, actually got to build the digital channel that we will be using for BART going forward in the Kafka infrastructure. This one project has really been the tipping point for us to really start our digital transformation journey. And move us into this, move us from this intermediate to this advanced level of digital transformation. We also, at the same time, have a ton of grassroots digital initiatives going on throughout the organization. And so those are helping maintenance or are planning and people that are deployment people. And so those projects happen all the time. And as part of this journey, we've really started to develop our digital strategy. And that's kind of, you know, and you think it should be the reverse, that, you know, you start with the digital strategy, but things happen very fluidly and you don't necessarily have the money at the beginning of these types of journeys that you may have later on. And part of this is we have been, as new projects come online, we have been saying you need to invest some money in the digital strategy. And so that's actually how we've been able to fund this project as we've moved forward, is ensuring that the digital data is thought about. And it's not easy for people who have been working on legacy technologies to start thinking in this digital way. That has been one of the biggest challenges we've had, is to get people to think differently about the things that they maintain, from mechanical devices to train control to all of this, and how to get them to start thinking about it when they're building their requirements and everything. So I'm going to give an example here of, you know, modernizing technologies, and here is our district channel. It's Kafka. And as you can see now, we have lots of systems starting to feed in, and this is just a small example. It would be very complicated to have everything on the screen. You see our ATS systems, our new Hitachi system in the purple up above feeding in. We have our train control and planning department feeding the scheduling data in, and that's being absorbed by our train control data. We have the destination signs in the field that are taking stuff from both train control and the schedule and feeding it out to the public. We also have our BART web feeds that go out to third-party vendors like your Googles and things like that do, you know, where can I find my next train, and also feeding BART.gov, so that customer passenger information. So as you can see, we've decoupled the systems in the back end and the front end, decoupled it and created this district channel. This has allowed us to quickly and rapidly develop in our environment, and increase transparency. And this is huge for us, because before, all this data used to be hidden from people. And so what this allows us to do is cut costs. It increases productivity. It improves the customer experience, because we're able to integrate the data better. And also from a development perspective, in the systems group that I'm in, we don't have to provide the data anymore. Anybody can subscribe to the channel, and there are simple tools on the back end and out-of-the-box integrations that allow you to integrate with the channel. drastically reducing my costs and actually increasing, the benefits to all the people that can now utilize the data. So let's talk about leveraging data. This is not easy. This actually has been my biggest challenge. We started out thinking, well, you just go to the end users and they just tell you what they want. Well, they don't know what they want. They don't even know what data they have. So the first step that we had to do was find key experts. And when we originally started, we just grabbed any user that would talk with us. Well, we found that not to be that effective. We really need high-end people that actually, when they look at the data, understand what they see because they're an expert in their field. We also have analytics specialists that work with them in gathering requirements. And then we have controls that happen as well. And as we bring in new sources of data, we work with these people and have these discussions. And in addition to that, we're integrating sources from different channels so that they even have more visibility into things that they need, things that they didn't even think could be possible in the past. And now we're starting to see the light bulbs are starting to go off with our end users about, oh, is this possible? Is that possible? And so building dashboards and the alerts that they need are now starting to come up. They're blossoming a lot quicker than they were when we started this journey. So the first thing I'm going to talk about from a climate perspective, and we're getting into dashboards and how we've been utilizing data in this section here. Let's talk about heat. Train delays happen because the rail gets hot or because the train control rooms get hot. And, this is an old system, like I said, and it was built in the 70s before global warming. Places like Oakland weren't hot. Places like, the Fruitvale BART station were not hot. That's changing with global warming. And so we never had air conditioning in those train control rooms. In the train control rooms in your Antioch and Pittsburgh, the temperatures are getting hotter out there. And so maybe the HVAC systems that we built out there to start with are no longer as good as they should be and need to be upgraded. Or we have issues with those HVAC systems and we don't even know about it, right? Or we didn't get the alerts because the technology is so old that it didn't alert us. And so this process of a heat wave for BART is was still kind of is labor intensive. You have to send resources to every single train control room. So you have an emergency group get together, they start dispatching field people, and they have a temperature gun, and they start going to each and every train control room and saying, is it hot here? Is it hot here? Oh my gosh, it's hot here. We need to mitigate that. Bring in fans, do all of these things that we do to reduce risk and reduce delays. That's very inefficient, costs a lot of money. And let me tell you, even with all of that effort, we had train delays every single heat wave. Fast forward to September and October of last year, somebody came to me and said, we have delays every time we have a heat wave. Can you do something about it? So we have, of course, new IoT devices for temperature sensors. We purchased those and we said, okay, let's using historical data from our incident tickets, tell me where the worst locations are for train delays due to heat and train control equipment failures. So they gave us 15 locations. We implemented those sensors into our infrastructure and we created dashboards and alerts for maintenance. We got into our first heat wave and lo and behold, temperatures rose. We were alerted immediately with text messages. The maintenance staff went immediately to those locations and remediated the problems before we had train delays. So in September and October, 0 train delays. And we had multiple heat waves. It was the first time ever that we have been able to not impact customers due to heat. So now that we have all this historical data, the mechanical engineering department said, well, let's look at trends for our data. And even though maintenance had been telling engineering for a long time, we had problems on the A line, it was kind of brushed off of, yeah, whatever. And now data doesn't lie, right? And so when we had the heat waves, we showed the spikes in those rooms, and now we have initiatives underway on the A line. And I even have a meeting this afternoon to talk about temperature in train control rooms because we're prepping for summer. And so one of the discussions is going to be this A-line train control room AC problem, and and how we can mitigate that. So next topic is water. Trains going through large volumes of water is not safe, highly risky. In December of this last year, I get a call from one of our executive managers to say, Wendy, we had flooding in the trackway. You said we had warnings. And so I went back to look at the data, and yeah, we did. We had 180 messages from that particular sump pump in the trackway, and the alerts were clearing within seconds. So maintenance and operations didn't even notice it. Like I said before, huge volumes of data that we get into our operations center, they only focus on things that are active. And so these particular messages were clearing too quickly. But I said, we still should see things, or, we still should see things. So I sat down with the mechanical engineer and I said, why is it that I'm getting excessive sump pump alerts? And he said, that's not normal. He looks at the data and he says, Wendy, sump pumps don't work that way. Now, I'm not a mechanical engineer. I'm just, a lowly systems person. It's good that we have experts like mechanical engineers. And he said, a sump pump should work is it gets a high water mark, it turns on, it clears all that water out, and you shouldn't see another alert for an extended period of time. Unless it's something like, a tunnel and excessive water or something like that. But normally this is not a normal scenario. So I said, well, what algorithm does make sense to you if a sump pump is behaving like it's not supposed to? And he says, if you get more than 10 high sump pump alert messages in a 24-hour period, somebody needs to go check out that sump pump. So we put those alerts into place. And in January through March, we had 3 major rainfalls. At 7 locations, we received high water alerts, and we found a myriad of problems: wiring problems, controller failures, clogged drains with grease and junk. And we were able to mitigate those problems before the flooding actually happened. This is also a first for us, right? Because we didn't have the algorithms in the past. Now we have them. And not only that, we are sending text messages to the people in the field that need to fix these problems. So they're there instantly. This is a game changer for us, the heat and the flooding. It's changing the way we do business. So, how we normally start here, as you see, we had maintenance with a problem. Now engineering has data, and they said, wait a minute, at S40, which is down in Berryessa area in San Jose, what is wrong with that sump pump? It's got excessive amounts of alerts all the time. And so now what this data is allowing us to do is focus our engineering resources on problem areas. So right now, there is a project underway to analyze what's happening at S40 from an engineering perspective, because that particular location isn't flooding, but it is not healthy from an engineering perspective. And so now that we have this data, the engineers themselves can actually be more proactive in solving problems and redesigning solutions to make the equipment work better. Another thing that we're working on is where we don't have sump pumps and we don't want to spend the money to put sump pumps, we are doing wireless. We have a pilot for wireless water sensors for areas that we think have water problems. It's inexpensive, it's fast to set up, and it can also send alerts and notifications through our new district channel, and we can get historical information. One of the things about these wireless sensors is, a lot of them communicate back to the cloud. We are very nervous about cloud technologies in our OT and our operational technology space. And so we are utilizing our IT infrastructure to pump the wireless data into a system on the IT side and function in that regard and utilizing the data over there. And so that's just to mitigate our risk from a cyber perspective with IoT devices. But the trending data is very, very good for us. So what about the future of weather for us? Since weather is really important, we are focused still on temperature, rainfall, and wind. So we are now in the process of tagging all the sump pumps in our district channel with sump pumps that will impact train movement. So now we've moved from give me alarms for every sump pump and I want to get out there and mitigate the issue to if I have 2 alerts coming in for sump pumps that have issues, let's focus our resources on fixing those sump pumps first, if I have limited resources, on those items that impact train movement. So now with additional data being added to our channel, we can now help maintenance more effectively utilize their limited resources. We are also partnering with UC Berkeley and USF. One of the projects that we're working on there is public weather stations. There are active APIs out in to the public weather stations, and we're incorporating, the students are working with us to map out our entire district and how do you explain this? Map out all of our critical facilities and stations and correlate that to a public weather station and start pumping that weather data into our district channel to alert us when we need to do a track inspection for either high heat or cold. And how is this different? Before we'd say, okay, Contra Costa County is cold, but I want to now be able to say, you know what, Contra Costa may be cold, but the critical location in Contra Costa is that's cold is Walnut Creek BART station. Go look at the track there first because that's our highest risk. So now instead of doing this, throwing out there and sending resources everywhere, we can now strategically move the track inspectors through the system in the best possible way, right? And so that project is underway. We also want to integrate rainfall because I want to say, okay, there's a sump pump that's going on like crazy and it's under Lake Elizabeth and there's no rain. I want to be able to say, go and look at this sump pump because if there's no rain, there's something bigger going on there and highlighting those as potential risk areas. We also have cover boards that protect the third rail, and it's very dangerous for field workers to be out there when the cover boards are not properly done, and also they fly off and cause problems with train delays. And so what we want to say in our aerial structures in areas that we know we've had cover board issues in the past, that if that particular critical facility has high winds, that we send out a maintenance crew to do an inspection. And that's really important for us to reduce delays. We also want to combine the temperature sensors that we installed to monitor train control rooms with also external heat, and so that we can enhance the train control monitoring. So for example, if a train control room temperature is starting to spike, that may be because the AC is broken and not because the ambient heat outside is too hot. And so we want to be able to know when we may be having equipment failures different than what, just dealing with a normal heat related incident. Also, because our pilot was so successful with temperature sensors out in the train control rooms, we are implementing more train control sensors throughout the district. So let's talk about other things. False occupancies in train control are not a good thing. And so we need to know where trains are on the track. And so we created dashboards for the train control engineering and train control maintenance folks so that they can figure out where we're having the most problems in the system and proactively work to mitigate issues in the field. This is an interesting, and these are dashboards out of Splunk, I should be clear on that. So basically, now that we've started implementing dashboards and a lot of dashboards, now people are coming to me saying, I am constantly arguing when we're in an incident about whose problem is it, right? Is it a network issue or is it a train control issue? And so with the VHLC components in train control, we now have a corresponding network alert for those. And we can now say, the train control people can now look at this dashboard and say, oh, wait a minute, there was a comm issue at the same time that I had an FO, and it's not my problem. And now we can have the comm person go out and mitigate the network issue that, in the past, they would just say, not my problem. And we'd have a lot of time lost in the troubleshooting because there was bickering between groups. The other not my problem, in train control, we run electric trains, and so negative ground is a big deal. And so we were having a lot of back and forth between train control engineering and electrical. And so they wanted this dashboard to show where the negative ground issues are in relation to train control issues. And this is just another at a glance for people to see where problems may be. So at the beginning of COVID, and I'm moving on to another example with power, is that we really need to use our resources efficiently. So because we've got a lot going on, but there's huge risks in circuit breakers on the high voltage, and we have to do preventative maintenance, and we do preventative maintenance on these breakers all the time on a scheduled route. But what we had seen is that because our aging infrastructure, between preventative maintenance cycles, there may be a problem. And how do we know that there's a problem there? Is there any data that kind of indicates that? And so we sat down with the electrical group and the maintenance group and said, let's look at the data and see if we see any trends. And what we found is that we bring down the traction power grid on our train control system every night, so that it allows us to do maintenance in the field safely. And what we do, we come out of the blanket and we re-energize the entire system. And what we found is if we get 2 or more circuit breaker closes within a 15-minute period, that is a very serious indication that we could have a fire. Could have a fire that could happen in the very near future. And so what we now do is if we come out of the blanket, and this is an example of we came out of the blanket, we had 4 circuit breakers with issues, immediately the maintenance teams dispatched to those locations. And we have found on numerous occasions that these were definitely problem areas, and we're able to mitigate them real time before they caused a fire or a critical incident in our infrastructure. So, this is how data and people that understand data and bringing them together is powerful. All right, line fans. This is a new initiative in mechanical engineering. Actually, this came out of infighting between maintenance as well in engineering, that, we had a lot of high vibration issues, and, maintenance kept going out there, and we really wanted the engineering team to know where they should focus in fixing the high vibration issues. And also we created them a trouble dashboard so that they would know where to focus their time. And so when we first put this dashboard together, there were a lot of issues, not a lot of issues, well, there were issues. And so we went out and fixed those from a mechanical perspective. And these 6 items that are left are not mechanical issues, but something either wrong with comm or with electrical. And so now we are to a point where we're able to focus what resources to send places, because we've been able to figure out, and we haven't actually implemented the network data for line fans into our Splunk infrastructure. So that's a future enhancement which will help this a lot, because then we can see if we have field related comm issues that could be potentially causing these problems. And then we could separate out those line fan issues and put them actually in a comm bucket. But that's, future, as we're learning more about our data, we're learning about what we need in the future. All right, so those are just some examples with dashboards. I have many more of those, but we only have a short period of time. So I'm going to move on to what happened in 2019 with the PSPS and the fires in the Bay Area, and wind and fires. It was apocalyptic here. You could barely breathe for those of you who were here. And we kicked up our emergency operations center. You can see that in our top picture. Nee Lee was she's the woman that's leaning over our track plans, trying to figure out what the heck we were going to do. We had a group of people in that room that were diligently working with field and engineering staff to figure out how we could keep BART running and keep the power and lights on in our infrastructure. And in that room, and with the working with engineering and with maintenance, we identified 12 vulnerable switching stations that were key for us in order to keep the entire system operational. And that was really important to narrow down where we needed to focus. We made adjustments and one of the switching stations was blacked out. Another station could pick it up and supply the electricity to run the trains. And so we came up with a very elaborate strategy of, if we looked at the PSPS dashboards, which I have to say were not very accurate in the beginning, we could then tell, and on the calls we were with them, it was very chaotic. I just want to say that the data between PG&E and us and the communications, we're kind of, BART is an elephant. We cover multiple counties, so we're not really a county. We are our own district, our own entity, because we own our trackway, so we're kind of this one entity, and PG&E never kind of accounted for that kind of one-off. We weren't a state, we weren't a county, we were kind of this weird thing. So it was difficult at first for us to get information. And so we started fixing those communication channel issues. And also what we worked with the emergency operations that were put in place by the state was to get generators into critical locales in our district for keeping tunnel fans and radio communication alive. And then we also focused on pinpointing the stations that needed to, which were most likely to be impacted by the power outages, and strategically put and install portable generators in those locations. All of you on this phone probably know that all those portable generators need gas, and so the logistics for going around the district and making sure that everything was fueled was a huge major effort for us. But I want to say we got through all of those PSPS shutdowns with not one impact to a station going dark, and the rail continued to run. That is a huge accomplishment for us, and I just am so proud of the engineering and the coordination efforts that went into making that possible. I mean, it's just amazing. I live in Rockridge. I live right down the street from the Rockridge BART station. My entire neighborhood was black, except for a beacon of light, which was BART. So it was great. So out of that, we got some RR funding to add more UPSs. Of course, when you have a tragedy, you realize that you need infrastructure. And so we are in the process of either upgrading our UPS systems or implementing new. This dashboard was created because as we're implementing new dashboards, we want to be or newer technology for UPSs, we want to be able to see alerts. But on the project side, we want to make sure that as we're implementing the new stations and the new stuff, that those indications are actually getting back to us. And so this is what the project teams are using to be able to tell if we in the data analytics world are actually getting the indications, or if the comm infrastructure is not set up yet. And this is a way for us to keep checks and balances between the project teams and the field teams at a glance. All right, moving on to COVID. COVID hit us like a brick. In March of last year, or actually, let's just say January of last year, we were riding between 450,000 passengers a day. Large volumes of people, and boom, we went down to about 25,000 people a day riding through our systems. Huge hit to our operating revenue. People did not feel safe riding public transportation. They did not feel our trains were clean enough. They didn't understand how things were transmitted yet. There was so much miscommunication at the federal level that it was very confusing for people to know what to do. And how we should act. So people just stayed away from transportation unless you were, didn't have a car, or your only means to getting to work was through BART. Those were pretty much our only people that were riding. Everybody else pretty much stayed away. In lockdowns, that even got worse. As of this week, we're riding about 50,000 passengers, just to give you a baseline. So we're not even, now that even with the recovery with vaccines, we're still running at very, very low levels. So part of that hit to operating is we could not run the same schedules that we were running in the past. And we could not maintain the infrastructure to the cleanliness levels that were, that we needed. So we started shutting down sections of the stations. We started putting new cleaning procedures in place. We changed our train schedules so many times it makes my head spin. Anytime there's a train schedule, my team that does the systems for running the trains has to automate all the changes in the system. And normally we do these schedule changes in a very, they take a lot of coordination because we feed data all over, as you saw in prior slides. And so getting all that data accurate and making sure all the downstream applications work properly and all that, it's normally, happens maybe once a quarter or twice a year, not like every other month or twice in a month. So the churn and, and what we allowed to not be clean data, just because we needed to get these schedule changes quickly, it was a lot of work. And I have to say, in chaos, you learn how to do things better. And so we've definitely streamlined our scheduling process and have, are making a lot of progress in that space so that we can do things faster, better, cheaper. But if we look at the other side of the house of how it impacted us internally at BART and our staff, we work in the field with people all the time, but also we have a large amount of capital projects going on where we could have up to 400 people in a trackway on a weekend doing construction work. And we really needed a way to track where our staff was at any given time. So we implemented an employee tracking system where we could, every day you check in, you say where you're at. It stores your historical data. So if there is an incident, you can quickly check the history and make sure that you weren't at that location that had a COVID outbreak. That's very helpful. It helped our contact tracing people. So that was one thing we put in place, and we put that in place for our on-site consultants as well as our employees. What also happened is employees wanted information. And so we put together a Teams alert channel and also a text alert channel that you could subscribe into if you really wanted real-time updates. So this is what a Teams update would look like. We have a positive COVID outbreak at the Oakland shop, and tells you the date. It tells you what precautions we are taking to sanitize. We would send whole maintenance teams in to do this type of sanitation. And it really helped improve the communication out to the field, and it helped people feel more comfortable about going to work because they felt that we had their best interest at heart. In the beginning, it was very hard for us to get, like everybody else, supplies, but over time, we have been able to get all of our PPE in order for COVID, and that has, now we have so much PPE. I have 20 sanitizer bottles in my office and a bunch of boxes of masks. It is such, I have to say, such a wonderful thing to have everything you need. I didn't appreciate PPE as much as when I didn't have it back in the March and April timeframe. So let's see, what else am I missing here? Oh, and what we implemented also due to COVID was a lot of these predictive maintenance initiatives. Because we needed to shift resources more for, shutting down stations and doing some of these COVID activities, we really needed the predictive maintenance to be really strong with our data analytics to make sure that we may have diverted people to deal with COVID-related tasks or COVID-related, we also shift some of our maintenance resources to do capital projects because our operating budgets were down for maintenance things that are less critical, that aren't risk or safety issues. We started diverting, but we still wanted to say if we had incidences with those, we needed to be able to monitor those things and get maintenance crews out there. And so that helped us a lot with the data analytics as well. So this whole shifting of resources and priorities and everything, and making sure that we're on top of things. COVID has, I think, made BART a stronger entity because we have made a lot of changes to adapt to this situation. And it's, with any bad thing that happens, growth comes out of it. So moving on to elements of the digital transformation that management liked. we are measured, and management is measured off their QPR metrics. And so for them, reduced service delays was their biggest win out of this digital transformation. Reduced delays means that their numbers go up, and that makes everybody happy. Because when we do have service delays, there's a lot of back end, how can we make this not happen again? And a lot of work that has to go on to explain things. And, that's all, a lot of time goes into, reducing our risks and improving our service. And, and so that was a big thing on our management's mind. Another thing that was important to them and showed is, as we were able to prove that we could predict things that we needed from maintenance, that was a huge win because it helped them reprioritize where they could send staff safely, right? And where we could catch things if need be. So that was a big one. And also, with that, this whole root cause analysis and focusing now on, how do we get more of this? There was this hunger for it as we started to show these proof of concepts becoming reality. The appetite for more of this was definitely great. And with that, as we built dashboards and tools, it provided management at all levels with visibility into things they were never able to see before. In the past, we had all of those alerts going to an operations center, and they were the eyes and ears to the plant. Now, management at any level can look at any type of technology, mechanical, train control, electrical, and really at a glance on a dashboard with very simple charts, see what's happening in that discipline. And that was good for them because now manager, like today, a manager came to me and he said, these line fan things, I realize it's a cross-discipline issue. I've got the spreadsheet. I'm going to go get it addressed. That's a different way a manager behaves now, right? Because he has visibility, he can now has data in his hands. It makes him a better manager. And so with that proof of concept and knowing that he can rely on that data, he now is utilizing it as a tool to do his job. We, as I talked about, we had the OCC, which is our operations center, but the managers of the maintenance team started building their own network operations centers as we've created these digital dashboards for them in Splunk. They now have throughout the district because we geographically put our maintenance staffs, they are putting in these very beautiful centers in, cheap, very cheap, few monitors and a computer out into these four workers' offices in office space so that they can manage their resources more effectively. And that's a big shift. It's not waiting for a call to come in. It's proactively looking at your displays and figuring out where and what you need to do. And we still have the feedback from our main hub, which is the OCC, but it's nice to be able to say from a maintenance perspective, the four worker picks up the phone to tell the OCC, yeah, I'm already on it. I got somebody dispatched. That's a different way of working, and it's really great to see that transition. In addition to that, as I showed in the examples above, we're reducing maintenance costs because we're working better, cheaper, faster. So on to lessons learned. Digital transformation is complicated, very, very complicated. The systems integrations take time to do. Getting the system owners to agree to integrate takes time. You think, this is a great idea. People may not buy into it, right? Or it's not their priority. And so having those discussions and negotiating between systems owners is incredibly time consuming. And also making that integration easy, like we did with the Kafka infrastructure, that you just have a plug and play type of approach to things, makes that discussion a lot easier, but it doesn't just magically fix it. In our infrastructure at BART, we have an IT department and an OT department. I manage the OT system side of the house. There's another group of people that run IT. And so there are systems on the IT infrastructure that I need to integrate with. And that's, that there's a lot of discussions about those priorities because IT has priority in building the back office systems, and I have priority, my priorities are keeping the plant running. And so, there's a lot of balancing act there from I call it political perspective, right? Is negotiating priorities between organizations is always, a challenge in no matter what organization you're in. And so that was something that I've learned how to negotiate through, and and we still are continuing to work on that challenge, right? User knowledge. I assumed, not a good assumption, that I could talk to anybody about their technology, and people had the ability to transmit requirements to me like magic. I mean, I've known that that's not the case because I've been in software development for a long time, but I thought with a mechanical device, I could just grab any mechanical person and they would be able to tell me how it works and give me that knowledge of the data. That wasn't the case. I had to show them the data and show them how I thought it would work and how the dashboard would look, and we would then have a discussion. So coming to the users with knowledge or examples and doing that was kind of a shift that we had to make relatively early. And also we had to iterate a lot. So we would create dashboards and we'd get them up, and then the user would say, yeah, this is great, but this doesn't work. Or we also got, well, this works for maintenance, but it doesn't work for engineering. So we would create two different separate views of the same data, but in the way that each organization wanted to see it. So don't think that when you create a digital transformation that it's not going to take a lot of trial and error to get to where you need to be, because it's constantly evolving. Especially as you get new channels and new data into the stream, you've got to educate your user base of what's now available and go through that cycle yet again of iterating to improve their visuals. The other challenge is cultural shifts. So, for example, at BART, having a system that was built in the 70s and the mindset of how it operates and how we deal with it is change, right? And people don't like change. I've been doing this work, Wendy, for 30 years. I've been working in this plant, and how we do it works. We know how to run this. And so, convincing people is tough, and it takes a certain group of people and a certain type of person to change mindsets. And so if you are an organization that needs to do a digital transformation, you need to find that skill set of a person or people that can help facilitate that adoption, or that digital adoption, as I say. You need a manager at the management level to champion the effort, because staff doesn't change unless management is beating on them to look at the data and change. You need training staff to understand the changes in processes and procedures and in tools. You also need people that can give the data out that people trust. Trusting the data it helps people adopt to digital transformation. Bad data causes people to run and flee from it. And, it's interesting, like in the FO reports that we created for train control, even though those dashboards have been up for a while and they use them all the time, I just got feedback this last week. If you could just tell me the FOs I'm having during revenue service, that would make this more useful. And it's like, well, why didn't you tell me that 8 months ago, right? So this whole iterative communication process and making things better and trusting the data and how to make the data even more trustworthy is incredibly important. And then the culture shift for the NOCs, getting maintenance crews that are used to getting information from an external source to do their work, now getting it from their own line staff, and themselves, the maintenance crews, able to look at the data, is a huge, huge shift. And with that comes a challenge, because a lot of the maintenance crews are not used to working with digital data, not used to working with these types of tools. And so training them to understand what they're looking at and understanding how to utilize the data effectively has really been a challenge. Just because you build a flashy new NOC with a bunch of screens and you think it looks so cool, which I do, doesn't mean that they understand what they're looking at, right? And so getting people to move to that next level of, excessively using the data and adapting and innovating on it is something that is huge, huge, huge and hard to do. And then the other thing is we have competing priorities. So, what happens first? Now that we've got people jumping on board to this digital transformation, now everybody wants a piece of it. And so we have to I only have, a limited amount of resources in my systems team to work on these types of projects. And so prioritizing the work, which constantly gets prioritized every week, and that's part of adapting, right? You adapt to the most critical things, but you also, low-hanging fruit that's going to, be the biggest return on investment. And how do you quantify that, right? Everybody asks me, how much is this going to save, right? And that's also been a challenge, right? Is, how do you know what to work on, and how much money do you invest, and and then of course, where's my next funding source going to come? So that's been a challenge on many levels. And then the last thing I want to talk about is IoT security. And we get IoT, Internet of Things devices from all over the world, and they are, I want to come out and tell you now, not safe. So when we implemented our first pilot of the weather temperature sensors, that IoT device, immediately upon connecting it to our network, and I connected it onto the OT network because that's where I needed it at the time, because I was going to connect it, and that was the only connection I could get. It immediately phoned home to China and started to try, a service attack. And of course, we have all the security tools. And BART, I have to say, is very, very fortunate. We've invested a lot of money in cyber technology and cybersecurity. And, we instantly found the issue like within seconds. But not all organizations have that technology in their infrastructures or would even know to look for it. And so just know, as anybody who's dabbling in this area, that this is something you've got to think about, and think about long and hard as you're rolling things out. So those are the lessons learned. I just want to say in closing that digital transformation is a mindset. And as you know, we now talk to our cars, we now shop, we do work, we're changing transportation. Everyone is thinking of things in digital ways, and that's what I want to leave you with. So, open for questions.
Cool. Wendy, that was fantastic. Maybe what we want to do is, if you want to submit a question via chat, we can kind of manage the questions that way. Wendy, I presume you have access and can kind of see the questions coming in?
I will do that right now. Okay.
And that way I'll extract myself out of the quagmire here. Looks like we'll start off with Ian until the comments get posted in the chat box. So Ian, why don't you go ahead and start with your question? I see your hand is raised.
Okay. Wendy, first of all, I want to thank you for an excellent presentation. It's a great overview. The question I have, or the comment you started to raise, in fact, you did at the end, that we have at least two complex systems going on. One is the physical engineering. The other is the social system. And one of the questions that I had is that in every system we've ever studied, there are early warning systems, the early warning signals that something is wrong. And the question is, how is the bearer of bad news treated? Namely, are the reward systems in sync such that a person feels free to raise problems that his or her supervisor may not like? Another one is the whole cultural analysis of the system, namely, what are the rules of the game that people know all too well in the BART system, what they can say and what they can't say? And has that really been studied along with introducing, all of this new technology and the data? I mean, you hit on a part that people don't like change, but
Right.
But, has anybody done a thorough cultural analysis of the silent rules of the game that govern the system?
Well, luckily for you, yes, we have. We had a incident at BART where we killed two of our employees. During a strike many years ago, and the CPUC came in and said, this is not good, right? We cannot kill people, and you as BART need to improve your safety culture. And I have to say that that is something that is inbred in us. I, as a manager right now, as a manager, have to take 30 hours of CPUC safety training. And that's not only safety training for, I don't want to be electrocuted by the third rail, but also cultural level training. And the staff themselves have been given training about how to assess risks, how to escalate risks, how to run the plant more safely. We have so many people in the field because we have so many capital projects that this is pounded into us. Management, for example, during COVID, the head managers would go out, even though they didn't need to, would go out in the field and make sure that staff was wearing masks at locations where they were doing field work. So it's for us, it is just hammered into us in every staff meeting we go to. And out in the field, we have procedures when you start work activity that you have to walk through your safety assessments and talk with everybody so they all know their roles and responsibilities. There has been a lot of process changes that were put in place, and it is part of our culture, and it had to be, because of the damage that was caused. Does that answer your question?
Yeah, to a large part. The other part, though, is that if I walked in the system and I did a number of interviews from top to bottom, I asked people, what can you say versus what you can't say? What do people want to hear versus they don't want to hear? I'm more than just curious what I would find. Namely, what are the silent rules of the game?
Yeah, so I can tell you from my own experience as a manager, I'm a group manager. I have division managers that work under me, and then I have principal engineers that work under me. We have open door policy all the way up to the GM. And I can tell you that staff utilizes every level. If they don't feel that I am doing my job, they go and open those other doors and make sure, or they escalate the risks up through, we do have a chain of command, right? So they escalate the risks and then we go out and talk with the other managers about it. I personally have not felt that anyone was not allowed to speak. I think there is discussion about ensure you go through your chain command first before you go and knock the cages of everybody above you, because those people are also busy. There is that kind of conversation. And I know that the field people, we have a union, and the union is very powerful. And if they feel that they're at risk, they file a grievance and they get monetary rewards if the grievance is legitimate. And so there are financial penalties to BART as an organization that encourage, it's a giant stick, right? If you have financial penalties as a manager for not remediating an issue, you act, and you act really quickly. So I actually do not feel that that is a huge issue at BART. I think our bigger issue is funding those projects that need to be funded because the infrastructure is so old. I think that is our bigger challenge.
Just one last thing. I don't want to hog from other people, but given your presentation and somebody who really knows the system, have you considered a worst case scenario where somebody, given this, could do the most harm to the system because she or him, they know the most, they have the most knowledge about the system and will know how to really bring it down? Have you gone through those kind of scenarios and taken action, talking about?
Yeah, I can give my example of that. We brought in the BART police person that coordinates those types of exercises, right? And we brought in my experts, and we had them create a scenario of a cyber attack for us, right? and how we would respond. We did that incident, and we also did if we were to lose like our major data center due to flooding, right? So we didn't know what the situations were in advance. They created the scenarios for us, and I can tell you the exercises were definitely informative. The cybersecurity exercise definitely got us the cyber funding that we needed, or that we kicked off those initiatives in the cyberspace, which was fabulous. And the risks to our primary data center actually got us funding for additional disaster recovery centers. So, you know, we do those exercises. I know they do them in the civil area as well. They have discussions about those types of risks. I am not involved on the structural side, so I don't have as much to share on that. But I definitely know we've done it on our side. We've done it for earthquakes as well as cathodic protection.
Thank you again. Thank you very much.
Cool. Maybe let's move to Esfandiar next. He raised his hand, and then Patrick had a question about the slides. Wendy, you're okay sharing these slides, right?
Yeah, absolutely.
Okay, and they will be posted on the CCRM website as this event moves into the archives. If you go back to the archives, you can get to the both the recording and the slide deck from our website. So with that, Esfandiar.
Thank you, Ron. Ron, did you go through introduction earlier? Because I joined the meeting a little bit late.
Yes.
Okay, so just quickly, Esfandiar Imani, I have like more than 25 years experience in energy industry, mostly in the risk management, operational and financial. Currently involved in a nonprofit focusing on safety, risk reduction, reliance and reliability in the Safety Cube or Safety 3 Corporation. Thank you, Wendy, for the presentation. Again, my apologies for joining late. You might have mentioned it earlier in your presentation, but looking at the rest of the presentation that I was able to, you covered mostly kind of the operational side of the and the risk involved, the operation side of the BART. How about the security aspects of it? And I don't mean just cyber security, just physical security of passengers, employees. I know you said you coordinate with IT. Where does the security, whether it's a BART police or regular police or other security aspects?
So for security, so we have a police department. And we also have a fire life safety person in our organizational structure. And we have what we call the operational control center that is kind of I call it the heart of BART, where, you know, incidents is kind of day-to-day operations happens. You know, there's a stabbing on a platform, or, you know, we're flooding in a station, or whatever is happening, you know, a tree fell down in the parking lot, or those kind of activities. So there's a huge coordination that happens between the police department in that operational control center. And then in addition to that, we have an EOC, which is an emergency operations center. So if something is too big for the OCC to handle, because they have to run the day-to-day operations, like a PSPS with the power grid, that would end up in the EOC, and there's a manager that is responsible for that room and the technology in that room, and also for gathering the resources required to handle those types of incidences. And then from the stakeholder perspectives, like the relationships between myself and IT and these other stakeholders in the field, I mean, I work I have a weekly standing meeting with the operational center to talk about, you know, whatever is coming up in their space, because I'm responsible for most of the tools and stuff that's in that environment, and working with them to make things better. And I also work with the police department as well. So it's, you know, there's a lot of collaboration between the groups. Does that answer your question?
All right, thank you. Yes. All
right, so let me go to Emery's question. the BART main control center in Oakland, how has their real-time screens changed more to look at more network OCs in control with them? So it's interesting, the operations center really, from a visual perspective, they have a new tool called EDM, which helps them with delay management. And I didn't show that tool, but it's basically shows where train delays are in the system. It also has an interface into BART Police, and it gives them all the police activity going on. And so it's a nice tool that consolidates data for them. That's a change that's happened, I want to say, in the last 2 years. That's new innovation that was developed in-house, really, really cool, and really helping us to focus our efforts on things. But the control center itself, so mostly they have relied on data in a system called ICS, which was developed by my computer systems engineering team. And that is kind of their main tool that they use to run the trains and the traction power and also get all the alerts from the field. I have to say, for them, they have not yet delved into the Splunk dashboard space yet. We're getting ready to work with the reliability engineers in that operations center to get them on board to do post-analysis work in the new tools. But for the most part, they're still utilizing the things that they had in the past. And they also have things like Maximo for asset management and ticket handling and that kind of stuff. The technologies that are changing, we just put in a new PA system for them. We're putting in a new system to manage the communications out to the field, and that's under development right now. So there are things that are changing, but their space is changing a little slower. We're in the process of building a new a new OCC, and with that is going to really come, I call it the facelift of technology. And that project is underway right now, and it's super exciting that it got funded and that we are in the process of making that a reality. So talk to me in 12 months and ask me how that is, and I'm more than happy to share where we are with them in the future. IoT, have you gone live with system-wide innovation that you could not default back to older systems because this trial was actually an error? Oh, yeah, that's a good question. So we do get some heat and cooling indications from our HVAC systems. And so in those facilities where we did have that technology in place, we just fell back to that. With the IO technology, it's not always reliable because these are really cheap devices. So something to take into consideration as you're rolling these things out is maintainability of the stuff, right? So in the stations that we had no, for example, cooling, this was the only, there was, it was better than nothing. So we haven't had anything with the new IoT devices that we've backed it out because it wasn't as good as something else. We may have swapped out technologies, but not an error. It was more of an error on the technology we selected, and then we just changed paths. We're very agile. I have an agile development team, and so we can adapt pretty quickly and change things if we don't like it. And it helps to work that way, because if you get stuck in an approach, you don't want to pigeonhole yourself. All right, Ian's question is really good, and one, it is part of soft issues that are hardest to solve. We simply can't put equations here to find out a solution. There is a lot of research work in the field, but the problem still remains. One of the issues is related to inadequate reward systems, for example. Yeah, I would agree with that. I mean, I think at a public agency, it's hard for us to reward people because I can't give bonuses and things like that. So, I find my staff works for food, but finding things that make recognition. We have a Thanks a Million award that goes to an exceptional employee that has done something in the last quarter that they've rocked it, and they get a jacket, and it's kind of a prestigious award in the organization, and people want those things. And it's you have to be creative about reward structures, right? I have in my staff meetings, I have a crush it thing, and it's, if you've crushed it in the last month with innovation or support or, anything with our core values, I recognize people on the team in staff meetings that way. It's really important as an organization, especially a public entity, to find ways to thank people. And just a simple thank you is sometimes enough of a reward to motivate people to do more. And a lot of time that's overlooked. All right, so next question from Sarah. Thank you for your presentation. I am interested in climate resilience, I can't speak. And I want to know if you have an insight on how to bring digital transformation from operational spectrum, where you include observations, weather data, to monitoring platforms, to the planning and strategic spectrum, where you could integrate forward-looking weather and climate cognizant standards to decision making and impact low impact or long-lived infrastructure. Yeah, actually,
Hey, Wendy,
sorry, that was a mouthful.
Yeah, it was me. Yeah, sorry.
So
let me know if you need clarifications.
Yeah, no, I don't. I actually am very familiar with this space. Actually, I taught environmental studies at Merritt Community College, and it's a passion that I have. Environmental studies. I call it my pet project because I know from my work in that space of how this is important. I think are still at BART at our infancy level in this. We definitely are looking at climate related changes to our infrastructure. And what I say, like when we're making decisions, like for our new OCC, for example, do you build it someplace where we could have, with climate change and water sea rise, where are the models for that? And let's look and see if, for example, this particular location is going to be underwater in 20 years. I don't want to build a $32 million center and have it be underwater, right? And so we are doing that, and we have a environmental person on staff, but is it yet, can I say that it's fully baked? No, I think this field is so new and the thoughts around it. I know our civil engineering team thinks about this a lot. I don't know if anybody knows this, but we're building, a tunnel through San Jose, 80 feet underground underneath an underwater lake, and, to 3 stations. And we're looking at this type of, water levels and climate and, is it, how is this structure that we're building 80 feet underground going to survive long term, right? Those are some of the things that in the big money projects that we're moving forward, we are focusing on that type of research. But it's, that's a mind shift, right, for a lot of people to start thinking that way. And you're definitely in a field that's needed. Hopefully that answered your question.
Yes, thanks so much.
You're welcome. And I see, Ian, you have your hand raised.
Yes, I asked my question before.
All right. So no other questions? You guys were easy on me. Thank you. And I really hope this was informative, and and I'm available for if anybody wants to send me any questions later on. I'm more than happy to talk with any of you offline as well.
Hey, Wendy, there are actually 2 other questions. Mark was looking for some clarification on Splunk.
Yeah. Okay, sorry, I scrolled down, but it didn't move. Okay, so Splunk and line fans. Okay, so our line fans in the field, especially for our tunnels, are very important. And so we get indications through SCADA for those particular assets. And we have alarms and alerts that we are displaying. Sorry, I'm getting a lot of background noise. Can somebody put themselves on mute? I think we're having technical difficulties. So, Mark, was there a specific thing you wanted to know about Splunk, or can I get a little clarification?
Just the definition of it, please.
Oh, Splunk is a data analytics tool that basically takes data from multiple different channels, data streams, and indexes data. And why is that important? Index data can then be cross-referenced and utilized together. So once you have indexing in place, it opens up a whole bunch of opportunities to massage and combine information. Does that answer your question?
That's helpful, but I assume that that's an acronym.
Oh, no, that's the name of the company.
Oh, okay. Thank you.
Sorry. All right. Next question. Even though you had remarkable results after deployment of sensors and analysis of data, how difficult it was to convince every layer of employee and management to move on the digital transformation mindset. Yes, what I say in this space is easy wins, like data sensors. It is a big bang. It gets people to think about it, but then people are off to their next emergency. And so I call it my charge. I mean, I am passionate about digital transformation. I work in an organization, I work in maintenance and engineering. Every other discipline that I work with does something with physical things. They build bridges, they manage mechanical devices, they touch things. I work in the virtual world, and it is very, very difficult to get those disciplines to understand the digital mindset because we think very differently. And so I have gone out and I call it my campaign. I do brown bags. I talk to executives. I talk to the line managers. I'm constantly reminding project teams about our digital journey. You have to keep reminding people, because you are definitely, if you are in this space, you are not their priority unless you have something that's going to help them, like a dashboard that's going to reduce their pain or something, then you're their best friend. But keeping that momentum going is, you have to be a cheerleader. and you may think people just automatically will come, and rally behind you. Everyone is busy, and that seems to be the problem. So hopefully that answered that question. And
yes, Wendy. Thank you very much. Maybe you should come to my company.
Thank you. My job here at BART is, I think it's one of the most rewarding things that I've ever done. I worked in private industry for a long time, and I really wanted to transition to a job that I could do something for the betterment of society. And taking the knowledge that I learned from the private industry and placing it on top of this very, this fast adopting beast that I call BART is amazing. So any other questions? And thank you, everybody, for this opportunity to come speak with you. And I really hope that this information can be used by others to, progress other agencies and other people to move in this direction.
Yes, thank you so much. Thanks, everybody. I think I'm causing the feedback, so I'm gonna go on mute. Oh, no, maybe not. All right, thanks, everyone. Thanks again, Wendy, and we'll be in touch.
Thanks, Ron.
Great, thank you. Bye.
Thank you.
Thank you, everyone.